Oh, we forgot something. No one said anything. What did we forget? Did we do y-intercept?
We don't need to.
We didn't. No, we didn't do y-intercept? No. Okay. Just forget I said anything. Let's just stick with what we're doing, okay? 2 x-intercepts and our point. Draw our u and we're done, okay? We don't need a y-intercept. We're fine. We'll live. Draw your u as best you can. We move on. Questions, concerns, comments, any complaints? Yes?
No, I'm confused why you brought up the
Why? I thought it was one of the steps. I didn't put it on there?
No.
Steps? Okay. All right. You're confused because I shouldn't have brought it up. In the 1414 version of this class, we care about every little detail, including the y-intercept. So I just had a little brain fart there.
So HK formulas are pretty much anything that we need to know how to do.
You need this formula on your little reference sheet for sure. Look, if it were me, I'd write the steps out. Right? I'd write first step, does it open up or down? Look at A, if A is positive, it opens up. Right? Just write it all down. All right. Should we do another one? No. Why don't we move on? And then if we have time, maybe I'll come back and do a different one. I'm going to keep the problem on the test pretty much like this. I just want to make sure you know how to do this. It's not going to be about like, ha ha ha, tricked you. You know, I want you to be able to just show me you know what to do. All right, now, there is going to be a word problem. It is going to be the rock or whatever. Remember, we're going to drop something or throw something or whatever, right? So let's do one of those. And here, I'll even give you this much. We're going to throw something up into the air, okay? We're not going to drop it. We're not going to throw it down. It's going to be thrown up, right? So let's keep it nice and kindergarten in here. Let's just throw a rock, okay? No bodies or anything like that, like we did. Remember I talked about that? Y'all didn't like it. Okay. No, we did talk about 9/11. Remember all that? No?
Yes, yeah.
Yeah.
We didn't say that we didn't.
I know. I was just kidding. I don't want to. Let's just get to it. Okay. Let's see. A rock is thrown. So you did like it. Thrown upward at 64 feet per second. That's the way we write that, feet with a little slash second. So we have a rock. It's thrown up into the air. It's given a speed of 64 feet per second is how fast it comes out of that person's hand, right? So a rock is thrown upward, 64 feet per second from let's say a 300-foot building. From a 300-foot building. Standing on the edge of a building, got this rock, I throw it up in the air, the rock's gonna go up and it's gonna go down, right? So first question is, find the function which gives the height of this object. Height of rock. I'll just put that. I'm abbreviating this so we can get through it. Find the function which gives the height of the rock. Second question, what is the max height of the rock? What is the maximum height of the rock? Question mark. 3, when does it reach its max height? Question. 4, when does it hit the ground? Ready? What do we need to do this problem? There's something you have to do this problem. You have to have a formula that I gave you in class, right? So if you don't, well, you can memorize it, but if you don't have that on your reference sheet, you better have it memorized. What is the formula?
Minus 16.
Something before that.
H over T.
H of t, the height of this rock will be equal to negative 16
Over
t squared plus v with this little 0 times t plus h with the little 0, right? And I explained to you what all those letters meant when we were in class, right?
Yeah.
This h with the little 0 is where the rock starts from, the height, right? The original height, which for us was what?
64.
The height.
Oh, 300.
300, right? So the height is not the bridge, the building, right? The height the rock left person's hand, 300 feet. And that v with a little 0 is the speed. V stands for velocity, so think of that as being a speed. And then h stands for height, so that's the height. So to answer number 1, all I do is I rewrite this, negative 16t squared plus 64t plus 300. That's the answer to part 1. Right, just replacing that with 300, replacing that with 64. Now I go to part 2. What's the maximum height of the rock? And the way that I told, like when I was explaining this to you, what I was trying to get you all to understand was that at the end of the day, this is a parabola, right? This is a parabola, and it opens down. And so if you imagine like this is the building, and there you are, you're going to throw this rock, right? If this is time, okay, if this is time, what happens at the beginning of time, the rock is here, and then you throw the rock, it goes up into the air, right? And it comes down and it hits the ground. Now, this parabola that you're seeing here is not the actual path of the rock. It's how high it is off the ground as a function of time. So what's most important to us here in this picture is to understand that this point right here, which is the vertex, right? This is h, right? And this is k. K will always give you the highest point, like how high it got, right? The h gives you what? The time that it reached its maximum height. So in terms of the word problem, I told you to be careful with this. This is asking for k, and this is asking for h on the vertex, right? If I say, what's the maximum height, I want k. If I went, when does it reach the maximum height, I want h. But you can't find k until you've found h, right? So you're going to be able to solve this problem before you solve this one. So let's get h. How do we find h? This is we're actually going to do number 3 right now. To get h, you use the formula negative b over 2a, right? And we didn't write it down, but what's a for us? Negative 16. Oh, I forgot the negative. Negative 16. What's b for us? 64. And what's c for us? 300. So what we're going to do is we're going to take the opposite of b, and since b is 64, I'm going to take negative 64. I'm going to divide that by 2 times a. A is negative 16. This is negative 64 divided by 32, negative 32, which is 2. So I made the problem up, so I made it so that that was a nice number, right? Questions? We've answered part 3, haven't we? When does it reach its maximum height? After how long? 2 what? 2 seconds. It takes 2 seconds. Throw the rock. It takes 2 seconds to reach its maximum height. Now, how high was that? Well, to do that, to answer part 2, part 2 of the problem, we actually need to find out what k is. And to get k, what we're going to do is we're going to plug 2 into this, right? Plug 2 into this. Negative 16 times 2 squared plus 64 times 2 plus 300. Be real careful here, all right? Order of operations. 2 squared is 4, right? 4 times negative 16 should give you negative 64. Okay, so that should be negative 64. This should be positive 128.
Yeah.
Positive 128. And then plus 300. So I believe it comes out at the end to be 364. $364 what? Feet. 300-foot building, right? Throw this rock into the air, 64 feet per second, leaves the hand, goes up, gravity takes over, right? Takes 2 seconds to reach its maximum height of 364 feet, and now it's on its way back down, right? And now I want to know, when does it hit the ground, right? It hits the ground here. And so we need to figure out how much time it takes for that to happen, which means we want like the x-intercept, basically, right? So to answer the final part, part 4, when does it hit the ground? So this is for part 4, when does it hit the ground? I set the original function equal to 0. Now, when I do this, I can either use the quadratic formula, right? Or if you know how to factor that, factor it. Or you can use synthetic. But I've got bad news for you. Synthetic doesn't always work. Every problem I've given you, I've made it so it works, right? But on these problems with the rocks and stuff, I can pretty much guarantee you synthetic's not going to work. So when you see this problem on the test with the, whatever being thrown in the air, just know that you're just going to go straight to quadratic formula here, okay? Just use your quadratic formula. Don't waste your time trying to factor it by synthetic or anything else, all right? So quadratic formula, you probably need that for the test, right? You probably need to write that down. Negative b plus or minus the square root b squared minus 4ac all over 2a. We talked about you could have that tattooed if you'd like. All right, so I need to figure out what that is. So what is negative b for me? Remember, I put a, b, and c here, right? So negative 64 plus or minus, okay, square root of, I'm going to need a calculator. Good, I hear calculators coming out. That's a good thing. Somewhere in here. We're going to square 64, right?
Yeah.
That's what I'm doing, 64 square. Your numbers are going to be big, but it's okay. We're just going to get a decimal at the end. All right, 4,096. Okay, b squared minus 4 times a, which was negative 16, times c, which was 300. All of this divided by 2 times a. So this is the opposite of b, plus or minus. That's b squared minus 4. That's a, that's c, that's a. Questions? Yes?
Got 4,096. Was that in parentheses or no?
What, when I put the 64 in there?
Yeah, I'm just curious in case it's like a thing.
Okay, so everyone, this is a great question. What if this had been a negative 64? This would be what? Positive, and this would be still positive because you're taking negative 64 and squaring it. So you're doing negative 64 squared, which is the same as negative 64 times negative 64. So if you're using your calculator, if this had been negative and you're using your calculator, you would want to do parenthesis negative 64 squared. You would not want to do minus 64 squared. Your calculator will give you a negative answer if you type it in this way. But you don't even really need to think about that as much. Like, just remember that this number is going to be always positive, no matter what. That number is always positive because it's a number squared. Okay? All right. May I continue?
Yeah.
Yes? The next thing that I suggested you do to avoid mistakes is to now look at the signs you have here. I have minus, minus, right? I have 2 minuses. And I told you if you see 2 minuses, that it turns into a plus, right? What if you see 3 minuses? It'll be minus, right? But this should be negative 64 plus or minus the square root of 4096 plus, right? Plus, that's going to be a plus. And now I'm going to get on my calculator. I'm not going to look at the signs. I'm just going to do 4 times 16 times 300. 4 times 16 times 300. 19,200. 19,200. And then all of this over negative 32. I just multiplied 2 times negative 16. All right. That becomes negative 64 plus or minus the square root of, okay, I want to go ahead and add those two together. 23,296 all over negative 32. And this is the point that you actually have to take the square root on your calculator, right?
It's 152.6.
I believe you. So negative 64 plus or minus 152.63-ish or something?
Yeah.
1 decimal is fine. Make sure when you do that step, when you've actually taken the square root on your calculator, don't write the square root again. Like you've already done that, right? So that's where we are. And once you're here, this is the point which I said you will now break it into 2 separate scenarios, right? You're going to have, okay, what happens if I use the plus that's in that formula? And then this is going to be what happens when I use the minus. So if I use the plus, it's going to look like this. Negative 64 plus 152.6 all over negative 32. And if I use the minus, it's negative 64 minus 152.6, and then all divided by negative 32. And if you remember when we talked about this initially, I told you one of these answers we're going to throw away because it's going to give us a negative time, and the other one's going to be positive. So let's figure it out. Make sure you do all of this first before you divide by negative 32. Who has that? Anyone have that yet? Like all of it?
Negative 2.76.
Negative 2.76. Let me confirm. Plus. So this is 88.6 on top divided by negative 32. Yeah, negative 2 point, let's just say 2.8, 2.7 something, whatever. And then this one becomes negative 64 minus 152.6. So negative 216.6 divided by negative 32.
6.8.
Yeah, about 6.8. All right, those are our 2 potential answers. And this one we're going to chunk because it's negative. This is 6.8 seconds. Seconds. It takes 6.8 seconds for that rock to hit the ground. Okay. So on the review that I sent out, email, there's a number 15, just like this, where a rock is thrown upward. Then there's number 16, it's thrown downward. Just skip that. I'm not going to give you a problem with downward. And I think that's all I gave you. Oh, and number 14, you just drop the rock. I'm not going to give you that either. I told you, upward, right? So just throw out 14 and 16 on the review. Okay, we doing all right? Okay, so let's recap. Lines, I give you equation, you draw me the line. Or I give you 2 lines, I ask you for whether or not they're parallel, perpendicular, or neither, right? I give you a parabola, I ask you to graph it, use the steps, or I give you the situation where we're throwing something up in the air and you have to answer all these questions, yes? All right. Last thing that you're going to be tested on is polynomial functions. Are you worried about time? Yeah. I'm not going to be able to give you a lot of questions on this test. Do y'all realize that? Like, this test is not going to have a lot of questions, just a few. So you want to make sure you're okay with them, because if you get one of them wrong, it could be like an entire letter grade. You know what I mean? This is not going to be a 20-question test where if you miss one, it's -5. This might be like a 6-question test or something. So what am I saying? Be prepared. Come in. Be prepared, right? All right. So the last type of thing I want you to do is something like this. I'm just going to do one of the problems that's on the review. And I should point this out. On numbers 1 through 4 on the review, I tell you in those to factor, right? That's what I tell you in the review. I say factor. Change those instructions to sketch, because ultimately that's what you need to do with these, is sketch these. All right, so what I'm going to do right now is I want us to sketch the function f of x equals -2x to the 4th plus 2x cubed plus 8x squared minus 8x. All right, now I know y'all are looking at that, you're like, what the hell, right? We have to sketch this. We are now talking about a polynomial function, right? And I gave you a set of steps to sketch a polynomial function. Didn't I? What were they?
Maybe you can break it down first, right?
See the end behavior.
End behaviors first. Y'all should check in your notes, make sure you have these steps, because I'm not going to put them all up on the board again. So the end behavior, I want to know what it's doing, right? On the end. To do that, I look at the degree and I look at the leading coefficient. What is the degree of this? 4. And the leading coefficient? -2. Okay, when I look at the degree, I'm looking to see if it's what? That's leading coefficient. Odd or even. Do you remember I made that little table? I drew it over there. Okay. So this is an even number, right? Even number. And then this right here is negative, right? Negative. So what happens when you have an even degree and a negative leading coefficient? What? Both sides go down. The left side goes down, the right side goes down, and in the middle, remember we put that question mark and we said we didn't know what happens? That's the first step. Second step, x-intercepts. You need to find out the x-intercepts of this, which means you have to set the original function equal to 0. Please be aware that the steps for the polynomial is not the same as the steps for a quadratic, right? It always hurts my heart when I'm grading and I see someone trying to do quadratic on the steps of quadratic on this. It makes me sad. Because then I feel like they really don't know what they're doing, right? Because they're just really disconnected from what we're trying to accomplish, right? So, different set of steps. Leading coefficient test gives you the end behavior, then the x-intercepts, and this is the part that sucks, right? We have to see if we can factor this. So I told you the first thing for factoring anything is always what? Greatest common factor. First thing, before you go to synthetic division and do all that, is there anything that all of these have in common? They all have an x, and they all have a 2, don't they? Now, I leave it up to you right now. Do you want to pull out a 2 or a -2? -2. Now here's why. Let's do it. If we do a -2 and an x out front as my GCF, let's write what we would have left here. So in other words, I think we talked about this a class or two ago. Basically take this and imagine dividing it by -2 and dividing it by x. What would happen if I took -2x to the fourth, I divided by -2 and x? This would go away, and then how many x's would I have? I have 4 of them, and then I take away, cancel 1, so 3, right? X third. Just check. If you multiply this times this, you get that, right? What would the next one be? Plus or minus? Minus. Minus what?
Minus 4.
X to the 2 power. There, what you're doing is you're taking 2x cubed, divide by 2x. When you divide those, you get -1, and then here, you have 3 x's on top, 1 x on the bottom, one of them cancels, you're left with x squared. What would this be? Do it again if you need to. 8 divided by -2?
That would be negative.
-4, and then x to what power?
X.
Just x. And then finally, you take the -8x and divide by -2x, right? By the way, if this looks not familiar to you, I have not done this in class. We have not done this, but someone mentioned it, I think, a class or two ago. Someone over here, I think, maybe.
That would be plus 1.
Let's be plus 4, just plus 4. Okay, so we pull the GCF, right? Now, the reason why it's good to have a -2 on the outside, the reason why that's good is because this leaves a 1 in front here, so it makes this real nice. What I'm going to do now is I'm going to take this, and since I'm going to do this separately, I'm going to take this over here, and I'm going to do synthetic division on that. So I need a list. My list comes from this number. Plus or minus 1, plus or minus 2, and plus or minus 4. Those are the only factors, right? How do you get 4? You can do 1 times 4, or you can do 2 times 2, but that's it. Those are your only options. So here comes my synthetic. What goes into the synthetic division box? 1, -1, -4, +4. And I'm going to start with 1, okay? I'm going to start with 1 out here. If I do a 1 out there, start playing this game, 1 comes down, 1 times 1 is 1. Ooh, check that out. When I add down, I get 0. Okay, 1 times 0 is 0, and I add down, I get -4. Hey, this is going to work, isn't it? +4? Oh, wait, -4, sorry. And then that's 0. Okay, what does that tell me? This tells me I have a factor of x minus 1. Remember the opposite of that number? And then this, because I have 3 numbers, right? I have 3 numbers. It'll be -4. And then what? Nothing in front of x, and then 1 in front of what? X squared.
So for this, like you know how, well.
You know that's a difference of squares? Yeah, then do that. But I'm going to assume that people don't, so I'm just going to continue. All right, so here's where we are, right? Let's just keep track of what we've got. What we've said is that this thing that we had tried to set equal to 0, we pulled out a GCF. We still have the -2x out here, but now it's turned in, this thing in blue here has turned into x minus 1, and then that piece that's still there is x squared minus 4 equals 0. I still need to figure out if I can factor this completely, and this is not completely factored because of the squared in here. If that squared wasn't here, then we'd be done. The reason why I need to completely factor this is because remember, this is where we're going to determine if it crosses or bounces and all that stuff. So I still need to work on this right here. Does it factor? Do you remember what we do? Continue with our synthetic.
Yeah, you do 1, 0, -4.
You have to do 1, 0, -4. Why do you have to have the 0 in here?
Because you have to have a placeholder.
You have a placeholder for the x, right? So I'm just basically taking these numbers again. And what number do we start with? We repeat, right? Because 1 worked, we try 1 again. It might work again. Now it's not going to, okay? 1's not going to work. So 1 doesn't work, what do I move on to? Negative 1. Negative 1's not going to work, okay? Do you want me to show that, or can I just skip to what works? Skip? Okay, 2 works. So I'm going to go 2. Okay, 1 comes down. All right, 2 times 1 is 2. Add down, I get 2, and then 2 times 2 is 4, and then 0. And that works. And so this tells me, and I should be clear here, what I'm working on right now, right, is this piece right here with synthetic. That's what I'm doing right here. Everything I'm doing over here, right, is that synthetic. So this turns into x what? Minus 2, and these two numbers turns into x plus 2. There's your difference of squares, right? So we have a final version of this factored. I'm going to put it up here, okay? So this line coming up here, we have negative 2x, we have x minus 1, and then x plus 2, x minus 2, and then equals 0. Questions? We're almost there. I'm going to set each of those equal to 0 now. So set that equal to 0. And the only way you can get that is if you divide both sides by negative 2, you get x is 0. You set the next one equal to 0, and you get x is 1. And you do the next two, right? Negative 2, you'll get x is negative 2 here, and you'll get x is 2 here. I should point out, I didn't say this, but what if this had been a plus 2 as well? What if these were both x plus 2s? Square. I put x plus 2 and then squared, and that would be critical because that would mean I bounce, right? Remember how that power tells you bounce? But let's get to that now. Bouncing and crossing. I want to know if I bounce across, so I look at the power on each of these factors, and hey, they all happen to be 1s, right? And that's, what are we checking for cross and bounce? For cross, you need that number to be what?
Even. Oh, odd.
Odd. Cross is odd, bounce is even. So these are all odd, right?
Yeah.
So we cross at all of these. We cross, 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 cross. Questions on that? That's called getting the multiplicity, right? All right. We're almost there. Time to draw it, right? All right, start with your x-intercepts. I have an x-intercept at 0. I have an x-intercept at 1. I have an x-intercept at 2.